Welcome to our third topic, Guidelines for Teachers and Students. In this topic, you'll be learning about the guidelines for the teachers and also for the students to make the conventional method into a greener technique. Green chemistry experiments are introduced not only drastically to replace the conventional ones, rather, they are considered complementary to the existing protocols. This methodology not only provides a wider view of various techniques, but also imbibes interest in innovative minds for future development and growth of the subject in general, with due emphasis to the green chemistry contest. The teachers may take periodical tests to judge the understanding of students about the experiments practiced. Whenever possible and feasible, the conventional process should be replaced with the greener ones to transmit the message of importance of green chemistry. Green chemical experiments should involve the use of alternative reagents which are not only eco-friendly but also easily available anywhere in the country in bulk quantities at very cheaper price. They should not preferably involve the use of organic solvents such as ether, petroleum ether or ethyl acetate, etc. Ethanol or methanol mostly preferred. The modified experiments, if possible, should not involve sophisticated instrumentation techniques like high pressure system, evacuated system, inert atmosphere using argon gas, etc. This is in view of stringent situations in many of the laboratories in most of the institutions of our country, especially in rural areas. The concept of green chemistry says that the experiment should avoid tedious experimental procedure like longer reaction time, reaction at higher temperatures, reactions at higher pressures, and so on. It also says that all the organic chemistry experiments like preparation, separation of mixture of compounds, identification of functional groups, etc. should be preferably be conducted in semi-micro or micro scale. Thin layer chromatography and spectroscopic techniques like ultraviolet, infrared, etc., wherever applicable, should be methods of choice for determining the purity, functional groups, and structural elucidation. The choice of starting materials is very important in the case of green chemistry. It is very important that a proper selection of the appropriate starting materials should be followed. Till now, most of the organic synthesis make use of petroleum chemicals and other hazardous or toxic chemicals which affect the workers handling these starting materials. Petroleum chemicals are non-renewable and these also require considerable amount of energy. Therefore, it is important to reduce the use of such petrochemicals by using alternative starting materials of agricultural or biological origin. Feedstock selection is largely dictates the reaction and conditions that will be employed in a chemical synthesis, and it should come from renewable sources rather than depletable resources. The ideal properties of the feedstock must be like it should be renewable, it should possess no hazards, it should be converted to desired product using few steps, and it should give 100% yield with 100% atom economy. Greener solvents should be used in most of the conditions. One can use ethyl chloroformate as a substitute for PCl5, PCl3, POCl3 or SOCl2. The acid is converted to its anhydride, which can be used for the same purpose. So one should be very keen in the selection of the green solvents, which will solve the purpose of green chemistry to some extent. Dimethyl carbonate may be used as a suitable substitute for dimethyl sulfate, and methyl halides for methylation, as the end product is only carbon dioxide. Preparation of a number of derivatives on large scale and assessing them could be dispensed with. Instead, students should be instructed or may be asked to report TLC behavior of the compounds prepared. On summary, it says that the teachers should take the periodical tests to judge the understanding of the students about the experiments practiced. Whenever possible and feasible, the conventional processes should be replaced with the greener ones to transmit the message of green chemistry. So here we end our topic, guidelines for teachers and students. Thank you.